All right, in this section, we're going to go back and just review a bunch of the exponent rules that you've already learned. It's really important going forward that we understand those and we can use those. So even though you've seen this before, this is something most of us need practice with. So 5 to the fourth, we know what that means, right? We know that 5 to the fourth means we take the base. That 5 is what we refer to as the base. And I'm multiplying it repeatedly. So in this case, we multiply it 4 times. And I know that because of that 4, which is referred to as the power or the exponent. So it means 5 times 5 times 5. Okay, when we go to work with exponents, there are some shortcut rules that can help us work faster. Plus, it also helps us deal with exponents that aren't necessarily whole numbers. And I'll show you some examples of that in just a second, in a little bit here. So that's our goal, right? We want to know and really understand and be able to use the exponent rules. So to do that, I'm going to go through and just some examples where we're going to write it out in expanded form and come up with the rule. Do this first part with me, and then in a second I want you to pause and do the rest. So it says, we have the product of 3 to the fourth times 3 squared, and we want to write it in expanded form. Okay, what that means is write it out. 3 to the fourth is 3 times 3 times 3. That's what we refer to as expanded form. Times by, and 3 squared is 3 times 3. And then we want to write it with a single base. So there's my 3 to the fourth. There's my 3 squared in expanded form. All together then, if you count those up, there's 6 of them. So that comes out to be 3 to the 6th power, just writing with a single base. Pause the video. Do the same thing with both of these next two examples. So 10 squared times 10 to the 5th, you should have gotten 10 to the 7th. 8 cubed times 8 to the 6th, you should have gotten 8 to the 9th. So what we want to come up with is a rule for, how can I go from here to here without having to write out the expanded form in between. So next thing is I want you to pause the video, write out a sentence. This is how it should start. It should start as, if I multiply things with the same base, then, and I want you to write out the rest of that rule. Should have said something like this, right? If I multiply things with the same base, keep the base the same and add the exponents, right? These both had a base 3. So you notice how the base stayed the same, okay? And then we just added the exponents together. 4 plus 2 is 6. The way you could write that algebraically is like this. A to the m times a to the n is a to the m plus n. Okay, so that's our first exponent rule. Okay, let's try another one. Oh, here's some examples actually. Let's do just a couple of these. So if you take number one thing to be aware of is when you're multiplying 3h squared, that's really the same as 3 times h squared times 2 times h to the 5th. And because they're all multiplied together, we can rearrange it. I'm going to write it up here. I could go 3 times 2 times h squared times h to the 5th. Well, I could multiply the 3 and the 2 together, and these two have the same base. So that's going to be h to the, I add their exponents, so 6h to the 7th. Go ahead and pause it, and you can try as many of these as you want, and then I will show you the answer so you can check it. All right, so this is what I got, number 2. I can times the 2 and the 3 together to get 6. If there is not a power, it's a 1. So the base stays the same, you add the power. So x to the 3rd. Again, y times y to the 1st times y to the 5th, you add their power. So y to the 6th. You look at the answer for example 3. Example 4, I times the 5 and the 2 together, you get 10. I have x to the 3rd times x to the 3rd times x to the 5th. The base stays the same and add up all those powers. And y to the, again, if there's not a power, it's a 1. So y to the 4 plus 1 plus 2 ends up being 7. Okay, so those are just some problems where you can see where we applied that rule where if the base is the same and you're multiplying, keep the base the same and add the exponents. Here is our next one. I want you to go ahead and draw this table. So I'll pause it for a second, draw this table, and then we'll do an example together here. So that 4 to the 5th squared, means to take 4 to the 5th, so 4 times 4 times 4 times 4. Right, there's my 4 to the 5th right there, and I have to square it, so I have to times it by itself. So I have another 4 to the 5th. So 4 to the 5th times 4 to the 5th. Well, how many 4s am I multiplying together then? Write it with a single base. Count those up. It ends up being 4 to the 10th. Do the same thing with those next two rows. So pause the video, do the same thing with the next two rows. Okay, you should have ended up with this. I'm not going to write it out in expanded form, but x cubed to the 4th ends up being x to the 12th. And y to the 5th cubed ends up being y to the 15th. So again, we want to write a generalized rule for how do I go. A lot of times we say call this a power to a power. I'll write that down. Call this rule because you're raising one power to another power. So if I have 4 to the 5th squared, how do I go from there over to there? Go all the way over without having to write out the expanded form. Okay, so you're going to pause the video again. You're going to write down this rule. You're going to start out by saying, if I have a base raised to a power to another power, then you're going to finish off that sentence. So go ahead and pause and we'll come back together. So you should have said something like, if I have a power raised to another power, then the base stays the same and I multiply the exponents, right? 5 times 2 is 10. 3 times 4 is 12. 5 times 3 is 15. Here's how you could write that algebraically. If I have a to the m to the nth power, so I have a power to a power, the base stays the same, and we multiply the exponents. So a to the m times n. Here's some examples that involve that. If I do number 5, x to the 4th cubed, that's a power raised to another power. So the base stays the same, and I multiply the exponents. Number 6, the base stays the same, multiply the exponents. 7 is just like that. That's what, 12 times 9. 108, I think. This last one's a little different because I'm multiplying, but I also am raising that b to the 3rd to a power. So make sure you follow orders of operations. I need to raise this to a power first before I can multiply. So I'm going to leave the 3b squared alone, 3 times b squared. B cubed cubed, power to a power, you multiply them together. Okay, the 3 stays the same, but the b squared times b to the 9th, now we're going to use that first rule, which we said, keep the base the same and add the exponents. So it ends up being b to the 11th. All right, so there's our second rule. So first one, if you times things at the same base, add their exponents. That was the first one. Second one, if you have a power raised to a power, you multiply the exponents. Okay, got a new table here. We're going to do the exact same thing. Go ahead, pause the video, write down this table, and we're going to do the expanded form, and then we're going to write them with a single base. All right, xy cubed means x times y times x times y times x times y, right? 3 times. So how many x's are multiplied together? 3 of them. How many y's are multiplied together? 3 of them. So it ends up being x cubed y cubed. Well, let's do the 2x. 2 times x times 2 times x times 2 times x. Oh, I need another one, sorry. Times 2 times x. So you end up with 4 2's and 4 x's. So it ends up being 2 to the 4th, x to the 4th. X squared y through to the 3rd. So we're going to do it 3 times. So times the x squareds together. X squared times x squared times x squared. Remember our rule is you add up the powers. So 2 plus 2 plus 2, 6. And there's y times y times y. So add up their powers, y to the 3rd. Hey, this fraction, 2/3, means 2/3 times 2/3 times 2/3. Well, if I multiply across, right, well, when you multiply, just multiply straight across. 2 times 2 times 2 is 2 to the 3rd. 3 times 3 times 3 is 3 to the 3rd. Okay, so what we want to do is we want to come up with a generalized rule. What happens if I have parentheses raised to a power? And inside there, notice inside these x times y, 2 times x are multiplied together. X squared times y. Now on the bottom, they're actually divided. So this rule applies to whether the factors are multiplied together or they're divided. But what's my shortcut from getting from here over to there? So pause the video, take just a second, write down the rule. So we say when we have parentheses raised to a power, and the inside is either multiplied or divided, what happens? Okay, we should have had something about, if you have parentheses with a power, the power applies to everything on the inside. So to each separate factor. So you notice how the x is raised to the third power and the y is raised to the third power. On this one, we have the fourth power, the 2 is raised to the fourth, and the x is raised to the fourth. On this one, x squared is raised to the third power, and the y is raised to the third power. And even on a fraction, when we're dividing, 2 is raised to the third power, and 3 is raised to the third power. You could write that algebraically like this. If I have a times b to the nth power, right, that you have to raise them both to the nth power. Oops, sorry, that's a b. Same thing if it's a fraction, if you're dividing. Same thing happens. So a to the m over b to the m. All right, that's our third rule. Let's look at a couple of examples. So number 9, I have 2y to the third. So that's 2 times y to the third. So you have to make sure you raise both of those to the third power. So 2 to the third times y to the third. If you want to, 2 to the third, you could multiply that out. 2 times 2 times 2, that would be 8. So 8y to the third. 10, you have 4x cubed, 4 times x cubed. So I have to go 4 to the third power and x cubed to the third power. Well, we could do a little simplifying that. 4 to the third power, 4 times 4 is 16 times 4 is 64. X cubed cubed. Okay, that's using our second rule, which is a power to a power. So I can write x and I multiply those together. I'm going to skip 11. It's a lot like 10, but let's do 12. All right, so again, I have to raise that power before I can multiply. So I have 5x squared y times by, I need to multiply, so I have to go 2 to the second power, x cubed to the second power, and y squared to the second power. Everything needs to be raised to that second power. So now I have 5 times x squared times y times 2 squared is 4. X cubed squared, multiply your powers. Y squared squared, multiply your powers. Okay, I can multiply the 5 and the 4 together to get 20. I've got x squared times x to the 6th, that's x to the 8th. I've got y to the 1st times y to the 4th, so that'd be y to the 5th. That's really as far as I go, right? I can't times the 20 by the x because I don't know what x is. So that's really as far as we can take it. All right, we'll just keep on moving here. So here's our next one, quotient dividing. So same thing, pause the video, write down this table. We're going to write about an expanded form and see if we can get the pattern so we can come up with a generalized rule. So 5 to the 9th over 5 to the 6th. 5 to the 9th is 5 times 5, ooh, a lot of 5s. There's 4, 5, 6, 7, 8, 9. 5 to the 6th. Okay, now think about what's going to happen here. I have factors of 5 on the top and the bottom. Those are going to reduce. So that 5s will reduce, those 5s will reduce, and just all the way across. So the 6 on the bottom are going to reduce with the 6 on top. That leaves me a 3 left over. So I end up with 5 to the third power. Okay, we're going to skip that last example, but let's do the x cubed over x squared. So x cubed, x times x times x, x squared, x times x. Okay, reduces, I'm left with an x to the first power. So think about what happens there. Again, and let's write a generalized rule. So this is how you're going to start. You're going to say, when I divide things at the same base, then, and you're going to finish that off. So pause it, finish off that sentence, that rule, write it down, and then we'll come back together. Hopefully what we saw was the base still stayed the same, right? It was base 5, it's still base 5. And then I just took the top exponent minus the bottom exponent. 9 minus 6 is 3. X cubed over x squared, again, the base stayed the same, it's still x. I take the top exponent 3 minus the bottom exponent 2. So I got x to the first power. So the rule is this. I'm going to write it algebraically. Is when you divide things to the same base, the base stays the same and you subtract the powers, the top minus the bottom. So here's how you'd write that. If I have a to the m over a to the n, right? I've got the same base. The base stays the same, and I subtract the powers. All right, let's do a few examples with that. So a to the fourth over a squared, the base stays the same. I subtract the powers. 4 minus 2 is 2. 3 is a little different because I have those 3 and a 6 in front. You can treat that just as if it were a separate fraction. You can split those apart. It's like 3 6 times x to the fifth over, I'm going to write that as being x to the first. Well, 3 to the 6 is just a half. The x to the fifth over x to the first, right? The base stays the same. You subtract the power. So it ends up being 1/2 x to the fourth. Something I want to point out off to the side here. If I have 1/2 x to the fourth, that's the same thing as saying 1/2 times x to the fourth over 1, which if you times those together, I get an x to the fourth on top and a 2 on the bottom. I want you to be able to recognize that answer and that those two are the same thing. And there's not one that's more right than the other. In fact, you could see it written both ways. I just want you to get used to it. So you could take the x to the fourth and leave it on top of the fraction, or you can drop it off to the side. Okay, 15. So I want to take the 25 over 5. I can simplify that, right? That's just 5. 25 divided by 5. Let's simplify those c's. That's c to the first. So c cubed over c to the first. The base stays the same. Subtract their powers. 3 minus 1. The d, same thing. Same base. Base stays the same. Take the top minus the bottom. 6 minus 3 is 3. Okay, last one, number 16. I have 7 over 49. Just reduce that fraction. And I'm going to write the whole thing I'm going to write it this way, just with a single fraction. That would be 1 over 7. Okay, the x's, I have x to the fourth over x cubed. That'd be x to the, subtract from 4 minus 3 is 1. And I have y over y. Now, just think about that for a second. Y over y, that just reduces, right? That comes out to be 1. And when you times by 1, it just goes away. So those y's are going to disappear. If, though, I use my rule that we just talked about, my exponent rule, right, y to the first over y to the first, the base stays the same, and I subtract the powers. 1 minus 1 is 0. What that kind of tells us then, that y to the 0 is really the same thing as 1, and we're going to talk more about that in just a second. So really, when you times by 1, it just goes away. So now I'm left with 1x to the first, which is x over 7. Now, if you wanted to, you could, like I talked about above, you could write that as being 1/7 x. Right? Those are the same thing. Doesn't matter which way you write it. So those can get a little bit tricky, but if you just take it a piece at a time, they're not bad. Hey, the last thing I want to talk about is, as far as rules go, are what happens if you have negative or 0 exponents. So I want you to think for a second. If I have x to the 6th over x to the 6th, right, that is just equal to 1. I'm dividing something by itself. But if I take x to the 6 over x to the 6, I could also use my power rule, which would be x to the, and I take the top minus the bottom. 6 minus 6 is 0. Well, what that tells me is that x to the 0 is the same, is really just equal to 1, which is kind of what we just talked about. So this is our 0 exponent rule. So you want to put down 0 exponent. Anything to the 0 power is equal to 1. So no matter what I do, if I raise something to the 0 power, it is equal to 1. Let's look at a different example. Let's say I have, let's say if I have like x to the third over x to the fifth. Well, there's two ways to look at that. I could just write this out in expanded form. And there's my x to the third. There's my x to the fifth, and those just would reduce down. So because there's more x's left on the bottom, right, I end up with 1 over x squared. Well, if I come back over here, if I use my rule up from up above, which is if you're dividing things at the same base, keep the base the same and subtract their exponents. Now, and it's top minus bottom. 3 minus 5 comes out to be x to the negative 2. So here's what I got when I used the expanded form. Here's what I got when I used my exponent rule. Guess what that means? Those two are equal to each other. So if you have a negative exponent, and you'll see in your directions, in most books or most math assignments, it'll say write without negative exponents. So we usually don't leave it with negative exponents. But the way we do that is we just take it and flip it over. We take the reciprocal. So here's our rule. This is the negative exponent rules. So if you have negative exponents, supposed to be an n there, sorry, negative exponents. So if I have a to the negative n, I just take the reciprocal. I go 1 over a to the positive n. By the way, that means if you have a fraction, I don't know, a over b negative n, that means you can just take that entire fraction and just flip it over. And that can get a little bit tricky because you only take the reciprocal of what you're taking, of what the negative exponent applies to. So sometimes that can get a little bit tricky, and then I'll show you some examples of how that works here in just a second. So, okay, those are our last two rules, zero exponent rule and negative exponent rule. So now you reviewed all the exponent rules. Let me show you a couple of examples with these two, and then you should be good to try the assignment. I'm going to skip past that. We kind of already explained that. Okay, so if I have this, x squared over x to the 7th, that would just be x, and I take the top minus the bottom, 2 minus 7. That comes out to be x to the negative 5. Well, again, don't leave negative exponents in your answer, so I'm going to flip it over. That's the same thing as 1 over x to the 5th. There's our simplified form. So here's a couple others. If I have 6.7 to the 0 power, well, anything to the 0 power is 1, so this is just 1. Okay, b is super tricky. This is one we miss a lot. We've kind of trained our brain that when we see negatives, two negatives, we're thinking multiplication and it makes a positive. Remember, a negative power doesn't have anything to do with the sign, with the two being positive or negative. So the first thing I'm going to do is if I have a negative exponent, I'm going to flip it over. So I'm going to write it as being 1 over negative 2 to the positive 4 now. And when I take that reciprocal, it takes this power and it makes it positive. Well, I can work that out. That's 1 over, what's negative 2 times negative 2 times negative 2 times negative 2. Those two together give me 4. Those give me 4. Times them together, I think we end up with 16. So 1 over 16. As far as that 0 power goes, one thing to be careful with, if I give you something like this, a negative, negative 5 to the 0 power as compared to a negative 5 to the 0 power. On this one does equal 1, negative 5, because the 0 applies to the 5 and the negative. If there aren't parentheses, what that means is a 0, it's like having a negative 1 out in front, negative 1 times 5 to the 0. So the 0 only applies to the 5. Okay, so that part's going to become 1. So you actually end up with negative 1. So if that makes sense, the 0 on here only applies to the 5, not the negative. But if I put it in parentheses, now it applies to the negative. Here's another one. If I have negative 4x to the 0, or if I have negative 4x to the 0 in parentheses, it's supposed to be a 0, sorry. So on this one, the 0 only applies to the x. So it'd be negative 4 times 1, which is just negative 4. On this one, the 0 applies to the whole thing. Negative 4x to the 0 is just 1. So you have to be really careful with what does the 0 apply to. Anything the 0 applies to is going to change to 1. So here's just a couple more just quick ones, really fast. Negative 9 to the 0 applies to the whole thing. That's just 1. 3 to the negative 3. Before I can evaluate that, I have to take the reciprocal. So 1 over 3 to the third. Well, 3 to the third is 3 times 3 times 3. Comes out to be 27. Okay, this one's got both, so be really careful. The 0 only applies to the 5. So I'd have negative 1 on top. And now get rid of your negative 2, so I got to take this and move it to the top. Now that negative 2 only applies to the 2, so I'm only moving the 2 to the negative 2. So the 1 stays where it is, times, and now it's 2 to the positive 2. We could keep going. That would be -1 times 2 squared is 4. So -4 is what that comes out to. So it can get tricky. Okay, on this one, y to the 0 is 1. So I got 3 to the -2 times x to the -5 all over 1. Now these two both have negative exponents. So they both need to move down to the bottom. So I'm going to end up with 1 over 3 squared x to the 5th. The 3 squared is 9. So you can see how that gets a little bit tricky, but just be really careful. Only move what it applies to. So if I had this, for example, I don't know, 5 over 10 x to the -2. Let's make it y to the -1 up above. So I could simplify the 5 over 10. That'd be 1 over 2. When I go to make these negative exponents positive, I am not going to move the 1 because the -1 only applies to the y. It's going to go down there, and that x to the -2 is going to go up there. So it'd be 1x squared, now positive, 2y to the first. So it can get a little bit tricky. Okay, went a little long in that video, sorry, but that should be a good review of all those exponent rules. That's what you're doing on the assignment. I've included the answers there also, so make sure you work through the problems and just check your answers as you go.